So this one is important topic, electricity and magnetism. Journal physics is one which is very important, as well as the electricity magnetism. The last we did was question page 1 and 2. Page 3. Figure 9.1 shows a graph for a current against the voltage. What the slope represent if the current is on y-axis and the voltage is on x-axis? What the slope represent? R or reciprocal of R? If the current is on y-axis and the voltage on x-axis, so it represents reciprocal of R. So what happened to the slope of this? It will represent reciprocal because if it was voltage on y-axis and current on x-axis, then it will be equals to R. What happened to slope here? Increasing or decreasing? Slope, angle. Slope is decreasing. Slope means the angle with the x-axis. If you see, this angle is much higher than this angle. This angle is higher than this. So what happened to the angle with x-axis is decreasing. So slope is decreasing. If a slope is decreasing, it means the resistance will increase. So means, and it is obvious the filament lamp, its resistance increases as it become hot, the temperature increase. State what happened to the resistance of a filament lamp as the potential changes from 0 to 1. From 0 to 1, it looks like a straight line. So what happened to resistance? Yeah, so if the slope is not changing, so resistance is constant. So you can mention it has a constant resistance from 1 to 8. The slope is decreasing. If a slope is decreasing, what happened to resistance? It increase because the slope represents reciprocal. So in this case, the resistance is increasing. At a normal brightness, the potential across the lamp is 8 volts. Calculate the normal brightness, the resistance of a lamp. So if the voltage is 8, first thing, whenever you are solving a question, you should always write a formula. So what is the resistance? It is a ratio between voltage and current. So V divided by I will give us the resistance. What is the voltage here? 8. So with this voltage, you have to work out the current. So when you draw a line, you have to show this on your graph. Like in exam, you have to show this that you draw a line from 8 volts and then find the current. For y-axis, 10 boxes equals to 0.2, so each is 0.02. So 0.62, 64, 66, 68, 70, 72. So this will be 0.72, 74, 76, 78, and 80. So this is 0.72. We need the resistance. So how to get the resistance? Voltage divided by current. So voltage is 8 and the current is 0.72. What's the answer? 8 divided by 11.1. 11.1. So this will be 11.1 and the unit is ohm. Then we need the power. The power is a product of voltage and current. So we've already worked out the voltage is 8 and the current is 0.72. 8 into 0.72. Current is 0.72 and the voltage is 8. So this will be 5.76 and the unit of the power is watt. So 5.76 watts. 5 of these lamps are operating at a normal brightness are connected in parallel. Determine the EMF of the power supply. Their normal brightness means all are receiving the same voltage what they want, like this need 8, this need 8, this need, like all are using 8. They're connected in parallel. What should be the voltage of a supply? What should voltage of a supply, power supply? 8. Why 8? Because whenever they're connected in parallel, the voltage of a supply is same as the voltage of the components across the components. But what if the same question was there and the five lamps were connected in series? And we say that they receive the same 8 volts. In that case, it will be 8 multiplied by 5, which will make 40 volts. So when they're connected in series, the total voltage will be equal to sum of voltage across each. But when they're in parallel, the voltage across each is same as the voltage of supply. The current from the supply, how we can work out the current from the supply? When they are working at a normal brightness, each lamp is receiving 0.72. This is also 0.72. This is also 0.72, 0.72, 0.72. So how much is the current from the supply? If each branch is 0.72, 0.72 multiplied by 5. Because we are the current divide in the branches, so the total current, some of the current will flow through the first lamp, some through the second, some through the third, fourth, and fifth. So whenever total current in parallel is sum of the current in each branch. So you can add 0.72 5 times or 0.72 multiplied by 0.72 multiplied by 5. So it will be 3.6 ampere. Describe in terms of the particles and the terminal of a battery the movement of a charge in an electric circuit. How the charges move in electric circuit. And which charges move in electric circuit and from which end. Like example, if we have a battery and any component is there, which charge will move and from which terminals. Describe in terms of particle and the terminal the movement of a charge in an electric circuit. Which charges move? Electrons will move. Yeah, so electrons will move. The charges which will, in terms of the particles, so the motion of electrons is there. And from which terminal it will move, like repelled by the negative and attracted towards positive. So it will move from negative to positive terminal. A charge build up on the cloud before a lightning flash is 0.6 coulombs. The charge is completely transferred to the ground in a like about 0.5 microseconds or 5 exponent minus 5 seconds. Calculate the current. What's the formula to calculate current? So current is charge divided by time. So charge is 0.6 and how much time is there? 5 into 10 to the power minus 5. So 12,000 ampere, which is a very high current because even 3 ampere or 4 ampere is considered as a large current. So it's a very high because the time is so short. That's why the current is very high. The potential difference between the cloud and the ground during a lightning is 2.5 exponent 8. Energy transfer. How to work out the energy transfer? If we have voltage, we have current, we have time. You can find the power and then power into time, or you can directly use a formula. If you have the voltage, current, and time, you multiply them. Voltage multiplied by current multiplied by time. VIT. So voltage is 2.5 into 10 to the power 8. The current is that we calculated in the previous part, that is 12,000. And how much time it was taking? 5 into 10 to the power minus 5 seconds. How much energy is transferred during this lightning flash? So 1.5 into 10 to the power 8, and the unit will be joules. Suggest what happened to the energy calculated in B2. What will happen to energy? What we calculated in B2. We calculated this energy, which was 1.5 exponent 8. But what happened to this energy? And the lightning hit the ground. Losses, heat or sound. Here, it is converted into heat or light or sound, because that's what happened. When the lightning strike, you will hear the thunder or a sound is there, and you will see the flash or the light as well. Figure 9.1 shows a potential and the thermistor current voltage. Again, what the slope represent? The slope represent the reciprocal of R. What happened to resistance of thermistor? Because the slope does not change, so the resistance of resistor is constant. But what about thermistor? The slope is increasing. So if the slope is increasing, it means the resistance is decreasing. And if it was a filament, then opposite will happen. If we were having a filament lamp, then the slope will decrease. Calculate the resistance of a thermistor when the potential is 7. So when the potential is 7, what is the resistance of thermistor? So this is a 7 volts. You have to show this on your graph, okay? So you have to draw the line. And find the current, which is 10 boxes equals to 2. So each is 0.2. So 4.2, 4.4, 4.6. So if we need the resistance, it is voltage divided by current. So voltage is 7 and the current is 4.6. 7 divided by 4.6. What's the answer? So 1.52. So the resistance of a thermistor is 1.52 and the unit should be ohms. Place it in a table, tick the boxes, indicate what happened to resistance of thermistor and the resistance of a resistor from 0 to 7. What happened to resistance of resistor? Does it increase, constant or decrease? So it was constant. But for thermistor, the resistance decreased. Thermistor and the resistors are connected in parallel to 7-volt supply. Calculate the current. Now, how we can look, if we have a thermistor, and we have a resistor, both are connected in parallel to a 7-volt supply. So how much voltage will be across thermistor 7 and what voltage will be there across the fixed resistor 7? We want a current. What will be the total current in the circuit? Current from the supply means current from the supply. So that will be equals to current in the thermistor plus the current in resistor, because they are connected in parallel. What is the current in thermistor when the 7 volts is there? It was 4.6. And if you see, because this point both meet, so the current in the thermistor resistor is also 4.6 ampere and the current in the thermistor is also 4.6. So what is the total current which enter the supply? So 4.6 plus 4.6, that is equals to 9.2. So the 9.2 ampere will be the total current. So in parallel, if you need the total current, add the current in each component across passing through each component. Then energy transfer from a supply in 5 minutes. So if we need the energy transfer, the voltage of a supply is 7. So which formula? Energy is voltage into current into time. How this we got as 9.2 ampere, the current from the supply. Voltage of a supply is 7, the current from the supply is 9.2. And how much time? For 5 minutes. So we have to convert into seconds. So we multiply by 60. So it will be 19,320 and the unit will be joules.